Hey guys, Mrs. O'Donnell here. I got another question about Delta Math. So this is one that I've gotten from a couple of students, and I've answered sort of one-offs, so I'm making a quick recording. Delta Math is really specific with how they want you to answer these questions. So this is this question is asking, let's see here, it says determine whether the equation below has one solution, no solutions, or an infinite number of solutions. Afterwards, determine two values of x that support your conclusion. So some of what I think you guys are struggling with on this question is a little bit of the computer programming, right? So if we check this out, let's see here. Let me get my pencil. So if we check this out, the question that you're looking at is x plus 3, right? Equals 7. And you know, hopefully, pretty quickly, that 4 is the only solution that makes that true. So if you put in 4, you end up with 7 equals 7. This right here is called a statement of equality. This is the part that actually shows, hey, this is true. You have a true statement. 7 is actually equal to 7. Okay, versus right here, if you look at Delta Math's work, that is a statement of inequality. That's a false statement, right? 8 is not equal to 7, and we know that because 5 is not the right solution. Okay, so let's check this out. Let's check out the answers that were put into this particular equation. So, we know that 4 is the right answer, right? And that's true. Okay, 4 is the answer that's going to make it correct. But the problem with this particular solution, right, is that the statement of equality needs to be 7 equals 7, right? Because what this is doing, what the computer's actually doing, is it's taking this x plus 3 equals 7, and they want to see that you can do the work, right? So usually a teacher might require you to then show, hey, I'm plugging in my 4, right? You'd be required to show this work, but this isn't far enough to show, hey, it is actually a true statement. 4 actually makes this equation true. But so you have to get to that statement. Oops, oh no. Ah, I lost control. A demon has taken over my... Okay, let's try this again. Oh boy, it's still going. Sorry, worst video ever. Okay, hang on. Let me see if I can fix it. Undo. Let's try one more time. 7 equals 7. Sorry, guys. Real life here. Okay, so now you've got your statement of equality. Okay, same thing for if they want to know something that makes a false statement, right? Just like they plugged in that 5, you'd have to, if you want to say 3 makes a false statement, you'd have to plug in 3. So you have 3 plus 3. This is the step that you're doing, not in the computer, and then you see that 6 is not equal to 7. So this is the statement that proves that it is false. Okay, 6 is not equal to 7, and that's what you would type in here instead of the 3 equals 3. All right, let's pause this. Okay, so now if we look at another example, okay, we have this new equation, negative 2x equals negative 6, and they want to know what number is going to make a true statement, how many solutions can you have, and then what number makes a false statement, right? So if we check out the answer that was given, right? So what makes a true statement is when x equals 3, right? Because then you plug it in and you end up with the statement of equality, negative 6 is equal to negative 6. You also have a false statement, and you could pick just about any number except 3, right? So you could plug in 4, you could plug in 8, you could plug in 100, you can plug in negative 10, whatever number you feel like is going to make a false statement. You just can't plug in the number 3 because that makes a true statement. So what the computer's doing is they're looking for your statement of equality that would make a true statement down here for whatever number you've plugged in, right? So this time, the solution is almost correct, except here you're leaving too much math to be done. While yes, teachers always want you to show your work, in the computer program, it's assuming that you are doing this work. And if you do that work correctly, you would get the statement of equality, -6 is equal to -6, right? The really cool thing is that down here, so for example, if you said x equals 1 would make it a false statement, right? The computer will know that you will get a false statement of -2 equals -6, right? They'll know what the computer will know what that answer should be just based off of what you're telling it the input is, okay? All right, I want to show one last problem, and this one's interesting. So it says 20 divided by x equals -5, and Delta Math says, okay, the solution is x equals -4, makes it true, right? And you get -5 equals -5. X equals 2 makes the equation false, right? And you get, divide 20 by 2, you get 10 equals -5. Well, if we look at the student solution, it says the equation has one solution, and that sounds good. A value of x that makes the equation true is x equals -4, which when substituted in simplifies to make the equation into -5 equals -5. So that looks really good. Value of x that makes the equation false is x equals +4, when substituted into the equation simplified and makes the equation turn into 5 equals -5. So from what I can tell, therefore we know x equals -4 is a possible solution to the equation, but it is not true that all real numbers are solutions. So I'm thinking that this is the part where the one solution is the problem with this answer, and that it's not necessarily one solution, it's that this equation has one possible. This is one possible solution. So there might be more than one solution. All right, so here's where I'm at with this solution. It looks pretty good to me. I just went and verified their only options to select for this one were one solution, infinite solutions, or no solutions. So the most logical one would be one solution. So I'm going to have to email with the creator of Delta Math to see what's going on here, because this looks pretty sound to me. Unless there's something I'm missing. But it could be a mistake in the program. So I'm going to send an email to Delta Math and see if they can figure out what's going on. All right, thanks so much, guys.